We're going to balance this chemical equation. We're going to balance this chemical reaction using the algebraic method. Since we have 5 chemical species, we're going to use variables A through E. We're going to create linear equations based off of the quantity of each atom type. We'll then solve those linear equations by setting one of them equal to 1 and solving for the rest. We have 3 carbons on the reactant side. We have 3 carbons on the reactant side and 1 on the product side. Notice which variable, which coefficient they're associated with. We'll do the same thing with all of the other things. Notice oxygen occurs in multiple locations on the product side. And so even though there are 6 on the product side, we'll say there are 2 with C, 1 with D, and 3 with E. We'll also be able to make note with our linear equations things like A equaling E. When we choose which variable to set to 1, we're going to choose the one that tells us the most about everything else, but also has the highest coefficient associated with it, if possible. This would be A. By setting A equal to 1, I quickly see that C equals 3. I have to do a little bit of math, but I'll see that D equals 4. I already know that A equals E. And now I'll have to use substitution to figure out how much B is worth. (2b) equals 6 plus 4 plus 3. This gives us 13. 2b equals 13. When I go ahead and do my division, I find out that b should be 6.5. There are only 2 rules to balancing. Make sure you have the same number of each atom type on each side of the reaction, and make sure that it is the simplest whole number ratio. Halves cannot be used. So, keep the ratio identical by doubling everything, and your half will now be whole. This gives us 2, 13, 6, 8, and 2. Notice A and E are still equal. We'll now show it with the trial and error seesaw method using a RAP table. The RAP table allows us to identify our reactant side, the atoms present in the center column, and the products on the right. We simply go through and count up the total number of each atom type on each side for our table. Make sure you pay attention to the order that they occur. This is why I did not fill it out CHSO on the reactant side, on the product side. We'll check to see which things are balanced, and then we'll try to balance out all the rest by changing the coefficients. In doing so, we will make some assumptions that certain things are equal to 1, at least for the time being. If something occurs in multiple locations like oxygen, it's best to balance something else like the carbon and the hydrogen and the sulfur first. Since sulfur was already balanced, it didn't get played with. But if we have to redo things, we will. Again, we assumed that the first chemical and the last chemical were both 1s in order to balance everything else out. When we finally solved for our oxygen, we had to double everything because we're not allowed to have halves. We get the same result as we did using the linear equation. Notice everything is balanced in the RAP table. We'll now go ahead and compare the RAP table and the linear equations to show that they're basically the exact same things. The linear equation will just break things up like oxygen. So that oxygen, even though there are 6 on the product side, it's shown as 2C and 1D and 3E, where the RAP table just simply says there are 6 of them.